My dad can now type a sentence into this box, and an AI coding agent edits his real WordPress website. That sounds like a terrible idea. The site has already been compromised once. My dad is not a developer, and the AI is changing the same source code that powers the live website. So I added the part most AI demos quietly avoid. If the change goes wrong, he can press one button and return the source to the last known good version. But the undo button is not the most interesting part. The interesting part is how this system can survive even when the website it controls is completely broken. This is Sahitya Cafe, a Bengali literary website that my father works on. It has articles, poetry, author pages, images, and the usual history that accumulates inside a WordPress site over time. Whenever he wanted a layout change or something stopped working, the practical workflow was familiar. He would describe the problem to me, I would find time to investigate it, and then I would make the change. That works until every small edit depends on the one technical person in the family being available. AI coding tools appeared to solve that problem. In theory, I could give him an agent and tell him to ask for what he wants. In practice, giving a non-technical user an unrestricted coding agent on a live server is a fast way to create a much more interesting family phone call. The question was not, can AI edit WordPress? It obviously can edit PHP and CSS. The question was, can I make the whole experience forgiving enough that my father can use it without me standing behind him? There was another complication. The WordPress installation had signs of compromise. That changed the design immediately. I did not want the AI portal to be a WordPress plugin. If WordPress crashed, the recovery tool would crash with it. If the WordPress installation was compromised again, I did not want the attacker to automatically inherit the control panel. And if a bad AI edit produced a fatal PHP error, my dad would still need a way back in. So Sahitya Studio is a separate application on the same VPS. It has its own authenticated login, its own service, its own state, and a separate Nginx entry point. WordPress can be returning a white screen while Studio remains available. That independence is the first design decision I would keep if I rebuilt this from scratch. In a minute, I will show you what the agent is allowed to do, because it is more constrained than the phrase AI developer on a server makes it sound. First, the actual workflow is surprisingly small. My dad signs in and sees one large prompt box. No file tree, no terminal, no deployment dashboard. He can write something like, make the article headings larger on mobile, and press the anti-gravity button. The portal starts anti-gravity CLI in the live WordPress source directory. It gives the agent the request plus a fixed set of rules. The agent can inspect the project and edit the files, but it is told not to commit, reset Git, use Docker, run system commands, touch the database, or wander into other directories. While it works, the job appears in the recent jobs panel. Only one editing job can run at a time. That matters because two agents changing the same theme at once would make rollback and review much harder to reason about. When the job finishes, the portal shows the output and refreshes the repository state. My dad can see whether the source is clean, which files changed, the current commit, and the recent history. This is intentionally closer to an appliance than an IDE. An IDE asks the user to understand the code. This asks the user to understand the outcome. The second design decision is that the AI never decides when its own work becomes the recovery point. That decision belongs to the human. After an edit, the website is live because the agent changed the live source directory. My father can open the public site and test it. The studio keeps showing an uncommitted changes warning until he chooses what happens next. If the result is good, he writes a commit message. The interface makes him click commit twice and warns him that he is creating a new recovery point. Underneath, the service stages the current workspace and creates a git commit. If the result is bad, he uses rollback. The service resets the tracked source to the latest commit and removes untracked working files while excluding the media and cache directories from that cleanup. We also allow WordPress uploads to be committed. Git is not the primary media backup system, but in this setup, it gives us a second copy of the uploaded files alongside the source history. The portal itself is almost aggressively simple. It is one Python file using the standard library. The HTML, CSS, JavaScript, HTTP server, authentication, job queue, and Git adapter all live there. There is no application database and no web framework to update. That is not how I would build every product. It makes sense here because the user count is 1, the workflow is narrow, and recovery matters more than scale. The process runs as the normal Ubuntu user under systemed. System makes the operating system read only to the service and only grants write access to three places: the WordPress workspace, the AI tools state directory, and Studio's own job state directory. The Python process also strips its environment before starting anti-gravity. The child receives a small known path, locale settings, and its home directory. It does not inherit the Studio password hash or the secret used to sign login sessions. Then Ginx handles TLS and proxies requests to the Python server on localhost. The Python server is not exposed directly to the internet. None of those pieces is exotic. The useful part is how they fit together. The agent has enough access to edit the site, while the recovery interface lives outside the thing being edited. Git is doing more than version control here. It is the contract between the AI and the human. Before the AI runs, there is a known commit. After it runs, there is a visible dirty workspace. The human tests that state and either promotes it to the next commit or throws it away. That gives the system three states my father can understand. The site is clean. The site has an uncommitted change. Or the AI is still working. I deliberately did not let the portal automatically push every commit to GitHub. Right now, its commit button creates the recovery point locally on the VPS. Remote synchronization is a separate concern and should have its own visible status. Otherwise, a network or authentication error could leave the interface claiming a backup exists when it only exists on one machine. This is also why the button has a real warning. Commit sounds harmless to a developer. In this interface, commit means, I tested this, and rollback should now return here. So does this work for anything beyond changing a font size? The first serious test exposed exactly why the job history matters. The live site had an author list page that was empty. The goal was to restore the authors and make the mobile version behave like an accessible accordion. The agent's first implementation was not correct. Public verification showed the page was still empty, so the next request told it to diagnose the active template instead of assuming the problem was only CSS. Then desktop testing found that the HTML hidden attribute was defeating the desktop layout. Another focused request corrected that. Mobile verification found a CSS selector that opened every panel. That needed one more correction. Finally, the style sheet URL was still cached, so the theme version changed to force browsers to load the finished CSS. This is what I like about the system. It does not pretend one prompt always produces perfect software. It makes iteration, visible, and recoverable. Each prompt gets narrower because the previous result gives us new evidence. The finished page now renders the authors in a clear desktop grid and uses the responsive behavior requested for smaller screens. There are still rough edges. If the service restarts during an anti-gravity job, the persisted job can remain marked as running, even though the worker disappeared. That needs automatic reconciliation on startup. The portal lists changed file names, but it does not yet show a full visual diff. It also creates local commits without showing whether they have reached GitHub. And its health endpoint only proves that Studio is alive. It does not prove that WordPress, Git, or anti-gravity is healthy. Those limitations are useful because they show where this idea should go next. A proper diff review, explicit remote backup status, safer recovery from interrupted jobs, and a simple test button that checks the public side before commit becomes available. I would rather show those boundaries than present this as a magical AI employee. It is a small operations tool built for one trusted person. What started as help my dad update WordPress became a different question. How do you give a non-technical person the useful part of an AI coding agent without making them operate a developer workstation? My answer was a private prompt box, a visible Git state, and a recovery button that stays online when the main site does not. If you support a website for a parent, a client, or a small organization, tell me in the comments, what is the first change you would trust them to make through a system like this? And what would you never allow? If enough people want it, the next video will cover the architecture and the exact failure cases I had to design around. Subscribe if you want to see that build, including the parts that did not work on the first attempt.